Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this Techstrong Learning Experience brought to you by Prisma Cloud. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting presentation ahead. Before we get things going, I do have just a couple of housekeeping notes to review. Today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude this live broadcast today. If you'd like to engage with us, there are a couple of options for you to do so, and they are all on the right side of your screen. The first option you'll see is the chat tab, and I'd like you to start warming that up for us right now by letting us know from where you are joining us. I know I myself am in Austin, Texas, and Steve is coming from KubeCon over in Europe. Steve, where is it this year?
I'm in Amsterdam.
Amsterdam. Very cool. Very cool. So if you have any questions for us, we would like you to send those over to the Q&A tab, which is directly to the right of the chat tab. We will try to bring those questions in as we get them. So send them in throughout the program and we'll sprinkle them in throughout. We do also have a couple of handouts that will be ready in the handouts panel here in just a couple of minutes. So I'll let you know in the chat when to check back for those. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program today. So our topic is Code Smarter, Not Harder with Dev-Friendly Security. And I'm joined by Steve Giguere, Developer Advocate at Prisma Cloud by Palo Alto Networks. Steve, thank you so much for joining me. I know you are in the middle of a busy week, but we are so happy to have you here with us in Techstrong Learning. Do you want to go ahead and get us kicked off?
Okay, no problem. Thanks, Cody. Yes, code smarter, not harder. Trust me, I'm DevSecOps. Your safety is in my hands, or is it? Safety can be in your own hands. I'm a developer advocate at Prisma Cloud. Actually, we might as well do the obligatory history of me, right? I am currently at KubeCon. I'm doing a lot of work here, filming and speaking to people about how to secure from a developer and DevOps perspective. I've been a cloud security advocate. I've been writing code since the 90s, across a variety of tech stacks. But in the past 10 years, I've been focusing on probably all the mistakes of my youth. Cybersecurity, namely, AppSec. I started off doing a lot of OWASP top 10 analysis, and then moved into containerization and Kubernetes, and now focusing on supply chain. It's all connected. If you do find yourself in London, England, I co-organize the DevSecOps London gathering. We've got a huge membership. We meet every month and we get a lot of really amazing guests in there talking about security. And additionally, every second Friday, I have a show on YouTube and Twitch called C9K, which is all about, I like to think more like a last week tonight about cybersecurity, the state of things. If you want to connect to me on LinkedIn, I'm pretty cool with meeting new people. There's a perfectly safe QR code, nothing to worry about there. Just go check that out. Let's get into it. Now, we're talking about DevOps, right? When we say DevSecOps, everybody gets a little confused. Let's scale it all the way back to DevOps as a starting point. DevOps is about culture. It's not really, you hear people say, I'm a DevOps engineer, and it's like, I don't know if that's necessarily a thing. It's definitely got an epic culture around it. It is a huge success, I would even say. The merging or the amalgamation of developer and operations into one, the communication that results from that is fantastic. It does have some characteristic elements, of course. For example, people carrying laptops in with 10,000 stickers on them. I mean, just the style of stickers, the style of fashion, it reminds me of almost like a skateboarding culture. It's a slight indie, it's a slight alternative. It's actually almost kind of cool. Now, from a security standpoint, how do security professionals see DevOps? Or how should they see DevOps when they are defining it? Well, they should see it meaning don't ever offer painful security. An acronym. But that is how we should do it. It's not always what we do, though. There are some really easy security-centric moves that you can make within your own developer and DevOps ecosystems that can do an awful lot to be secure and will be, I can trust me, valued by your organization. What is DevSecOps? Okay. Sometimes people say it's easier to say what it is by what it isn't. When I first heard the phrase DevSecOps, I must admit I was skeptical. And I defined it as a self-penned invitation to the success of DevOps by lonely security teams. That's my quote. I'm coming around. You noticed I do now run a meetup that's called DevSecOps London Gathering. So something must have changed in my head. I went to go find a better definition than my skeptical critical one of my earlier DevSecOps years. And I thought this one was pretty good. A software development approach, that's a good way of saying it. It's prioritizing security, but more importantly, ensuring it's not an afterthought. Now, how do we do that? Well, there's a variety of different ways to do that and terms, and we're going to come to that next. Now, if you're wondering where I got this amazing quote, well, it wouldn't be April 2023 if it wasn't ChatGPT, right? I asked ChatGPT to define DevSecOps, and I must admit it did a pretty good job of it. The next question, what is shift left? I was once doing a presentation in Scandinavia, specifically in Copenhagen, and these were all developers. It was co-located with Rancher, where I love those guys. And I said, raise your hand if when I say shift left, you know what I'm talking about. Now, I think things have developed, people are understanding what it means, but a fair few actually raised their hand. And that was a real light bulb moment for me, because security people are throwing this thing all over the place. There's companies who have shift left in their name and their marketing, and it turns out no one knows what it means, and it's aimed at developers and operations. We have a bit of a problem there. Now, my skeptical brain again, once I heard shift left, was, oh, it sounds like let's do the time warp again from Rocky Horror Picture Show. A little jump to the left, a little step to the right. I thought it was quite fun and actually pretty apt, right? We don't want to throw everything all the way to the left, although that is sometimes a bit of a misunderstanding. It's not security making or forcing developers to do the security for them. It's not that at all. These are what the lonely security teams think. Now, the concept of shift left, this is the practice of integrating security and automated measures as early as possible. Possible is a very important word here. If it can't be done, it can't be done. Sometimes it can't. But we want to explore that and see what we can do. And that's essentially the nature of this talk, is to see what you and I can do to make things better as early as possible. And by the way, that was also ChatGPT. Yep. If you're not using it, certainly saves time. Let's take a look at our shifting left security and code journey, right? Here's a very, simply drawn pipeline with some interesting things across the bottom. Software starts on your desktop. Maybe you're using VS Code. Maybe you're using JetBrains as an IDE. You might run some command line on it just to see, or you might have pre-commit hooks arranged just to do things before you check them in. Almost all code goes through a CI process. That's the eye of the needle. That's the narrow part of the hourglass. And actually, it's a pretty great spot to put security. Now, where security has traditionally been executed and where security professionals, dare I say, sometimes maybe use it to justify their existence, is over there on runtime. Now it's all done, it's all there, and there's a whole lot of complex monitoring going on with messages and logging and aggregation, maybe even some AI going on to try and figure out what is anomalous behavior, what is intrusion, what is potentially malicious behavior even look like. This is a lot of work, and there's not that many people doing it. You can see I'm going from thousands of devs to hundreds of ops to 10 security. There's a lot of people out there saying, oh, for every 100 devs, there's one security person, as if somehow that's bad. It's not that terrible. It's just kind of typical. There's a report that's released fairly regularly. I don't know if it's yearly or not, called the Billing Security and Maturity Model Report. And that's where that number comes from. Those are real world analysis of how organizations generally look, right? So it does mean that complexity is required. If you have very few people, you need to automate and make a lot of interesting things happen. But it's not the best place for security to live. The best place is as early as possible, distributing security. The easiest place, however, is there in CI. The deployability of security is very high. Operations, whether they realize it or not, they know how to do security. There are plugins for every CI platform to do just about anything you could possibly imagine, and you probably are already using plugins for code coverage or testing and a variety of potential linters. So you probably already have a whole bunch of stuff that is deciding through automation whether a pull request can be approved in advance of any human even looking at that code. So why don't we put as much security there as possible? It's also an environment where DevOps are familiar with. It's not like they're going to a new dashboard. It's not like they're having to download or install anything in particular. It's just kind of there, and it just kind of works. Now, our security nirvana, again, almost never, ever happens, is to do it all the way over there. And this is where I'm going to attempt to coax some of you, hopefully, to do a little bit of this after we're done talking. The ability to find and fix things at scale. If I get 1,000 developers to spend 10 minutes a week on security, that's going to mean way down there at runtime, things are going to get a lot quieter and a lot easier. And we're going to talk about the top 3 attack vectors, let's call it, that developers can definitely take a real bite out of as early as possible. And they can do it in a really, really easy way right in the IDE or on the command line. I'm going to show you a couple of variations of how you can make that happen. Now, you might be thinking, security's trying to push security stuff on us already. And this is just a little analogy of doing security as early as possible. This is not a foreign concept to us, not a foreign concept to anyone, really. I just landed in Amsterdam, and I'm going to be flying off to B-Sides and RSA tomorrow. Actually, if you're there, come by and say hello. I'll be at the Palo Alto booth. When you're going through an airport, and I'm going to have to do this tomorrow, again, for like the 100th time probably this year, I packed my bag. And you probably, if you're like me, you kind of pride yourself a little bit on being good at packing your bag. You know exactly how to get the maximum amount of stuff in there. I have a whole portable office that I pack. Make sure you've got all the little tiny travel stuff because you've got your little bag. And you're probably even very good at getting your belt off all in one go in the kind of Indiana Jones style flair and getting it into the bin. So that's all security. That's all, in a way, an analogy for great DevSecOps. Now, you go through the same process, though, because what's going to happen if you try and push code? Well, they're going to say, do you know what's in your code? And you're going to lie and say, yeah, I built that container myself. Has anyone given you anything to carry? They always ask that. And it's like, it seems like an obvious question. And generally you say no. But when we're talking about software, that question is really asking about dependencies. Are you aware of all of the dependencies, particularly the open source dependencies that you might be using or might not even know you're using because they were used to build dependencies that you depend on? Oh, it's the word depend an awful lot. Then, of course, they don't believe you anyway, and they're going to scan your bag. This is going to happen. Any code that you upload, if automation is in place, something there is going to scan it. So you don't want to be the person who, in this particular case, goes down the carousel of shame and they have to say, hey, because this is a true story. And the true story was, I'll do the reveal, because when you do, you'll realize they scan you as well. You go through and they scan you. They don't believe that you're not trying to carry something through. You get through, and then you're waiting for your bag to come up because you want velocity. You want DevSecOps velocity. You want to get on that plane. You want to deploy into the cloud. So the analogies just never stop. And so you lean over the carousel, even though you're confident. I have a tendency to lean on it and try and see if I can see the X-ray. Because if you can see the X-ray, then you get some insight into what your bag looks like, from the security perspective, and not always what you expect. Now, the reality of this was that I actually had a wrench once in my bag. It was a spark plug wrench, which has a cross section and kind of looks like a weapon, unfortunately. And it went down the carousel of shame. And I thought, oh gosh, what did I leave? Like a bottle of water in there. And before they even talked to me, a certain, let's call him the penetration tester, showed up and decided to convince me to be better at DevSecOps. And this is a very tight analogy because you really do not want to talk to security people if you can avoid it. They can be a bit brutal, and they can be a little boring, actually. So you want to stay where you live, and this is what I'm going to try and emphasize. Now, you're probably thinking, if you're into slideware like I am, that this is really small. I can't see what it says. You're not meant to. This is just meant to represent where developers live, usually in 2-point font on the biggest screen on the planet, probably 3 of them, looking at thousands of lines of code all day. I think as security professionals, and particularly vendors, we need to understand this. We need to acknowledge it. We aren't asking to change developers. Some people are, they will fail. All we want to do is learn how to integrate into the world of DevOps such that we can accomplish that wonderful world of thousands of developers doing a tiny amount, which amounts to an absolute amazing result as things go through, and really ultimately increases the time to release code, not decreases it. Where else do you live? I tend to live in GitHub. That's pretty popular too, or whatever CI platform you're using. And you can see down the side the list of actions in this particular repository. There's some security ones, but there's CodeQL, there's coverage, there's linters, and there's a variety of other things that are already part of our CI environment. Now, because of this, it's not a gigantic step to add a few security checks if we can. Now, I still don't want to break the bill. I still don't want to be that person that fails my security checks. That would be a little bit disappointing, but it is a familiar territory for me. If something happens here, I'm used to the language of this. So let's try and live there as often as possible. Where do you not live? Well, this right there, some of you probably never seen a Prisma Cloud dashboard before. This is a starting point within our main product. You can see incidents, exposures, misconfigures, identity risks, data risks. Security people love this stuff. You do not, and I never expect anyone who's a developer to log into something like this. And again, as security professionals, we need to understand that that's not going to happen and start trying and probably stop making tools that assume you might care. So what are the challenges that we face as developers, as operations, as DevOps in trying to get code out? In terms of security, of course. Vendors. I work for one. We are kind of part of the problem sometimes. We make products that are designed mainly in the security realm to jingle the shiny keys in front of the security people that actually have all the money. Is that actually an operational solution? Well, if we're not asking you, the DevOps people, whether you like it, it might not be, because DevOps, did you see the numbers? 10 to 100 to 1,000? You have a lot of power. If you don't like the security thing that's there, you're probably going to find some way of shadow ITing your way around it. It's not that hard. Alternatively, vendors can have a bad security strategy where they target only security. That's not very good. We need you in the room. The other problem, the security teams themselves. They can often have outdated perspectives. I don't have a slide that has a picture of a security person. I did once before, and all I did was find a picture of a guy wearing a white collared shirt. That's kind of your security person, right? I know some really great CISOs that are from very modern organizations, and they blend seamlessly into DevOps teams. But the ones that have outdated strategies look like, they seem kind of obvious. And we want to make sure that they advance into a DevOps culture. Security teams can have siloed objectives. Now, DevOps, we should be learning from. If you look at application security, you might think of OWASP top 10. This is the top 10 list of things that can go wrong when creating applications. There's also information security. And this is generally associated with hardening the environment. Well, the reality of DevOps and the move to containers and Kubernetes and cloud native means these two are integrated. And sometimes security can be a little bit behind in realizing that we need to also integrate application and information security under a single umbrella, because it's absolutely essential that we know that. And this can be a bit of a problem within organizations. Security theater driven. I did talk about how runtime, a noisy runtime, justifies the existence of a security team. It's not a healthy, necessary situation, but it can happen and get in the way. And there can actually sometimes be a non-shift left vibe that can come from that. Finally, challenges DevOps. Wait a second, how are we the challenge? We are only the challenge in that we don't always know what's expected of us. What's the easy thing I can do? I don't want to log into a dashboard. I don't want to do this. I just want something that is simple. Also, it's great for me to know, how does insecure software get created in the first place? Because then I know I have the knowledge to take action and make data-driven decisions. Okay, well, let's start there. How is insecure software created in the first place? And by the way, I should say, if you have questions and you're watching, fire away. Let me know. I don't know if there's anything in the chat. I'm just going to go check now to be absolutely sure. Oh, look, somebody from Toronto. Hi there. I'm originally from Canada. I suppose I'll answer that unasked question already. All right. How is insecure software created? Well, a variety of ways. And one of the main ones is time to market pressure. Way back. This is a great example. I don't have it on the slide, but it just occurred to me. I used to work with the team that found a very famous vulnerability called Heartbleed. It was in OpenSSL. I think it was around 2014 it was published, but it was a product of a GitHub check-in. I think it was something like 5 minutes to midnight on New Year's Eve. That is a alternative version of time to market pressure, where I got a party and you checked in one of the biggest bugs in history. That's a weird kind of claim to fame. The more realistic version of that is your software is very feature or money and not really security driven most of the time. A lot of product managers don't throw, hey, if you make the most secure code and you have the least detectable misconfigurations or vulnerabilities over the next 6 months, I don't know, you want a BMW. How about that? Other car brands are available. I mean, just something, even a box of candy be great, but that tends not to happen in organizations. And actually, if there's any product managers who are watching this, just throwing some ideas out there. We are very open source influenced is the other way insecure software is created. Open source is amazing because it does speed up that time. It aligns well with time to market pressure. Don't reinvent the wheel. That's not going to necessarily help you. And open source is out there to do just about anything you can imagine. However, it is open source that has a lot of these vulnerabilities that can bite us in the backside if we're not careful. And even more so, open source uses open source. And so it can be a real problem if we don't know the breadth or we don't have good visibility into the bill of materials that we are using in terms of open source. And the last one, I think it's the last one, is innovation. Like, how can innovation create insecure software? Well, it can, because code we used to use and write using something like Java, which was very popular in more monolithic software releases. We're using Rust, we're using Go, we're using modern languages and modern technology stacks. We're putting them into containers, we're throwing them into Kubernetes, which really isn't that old. And it changes everything. A lot of the perspectives, a lot of the way you can create systematic vulnerabilities is now completely different. In addition to the fact that modern languages don't have the breadth of tooling available to do even basic static analysis sometimes on them. And that leads me to outdated tools. Outdated tools and automation is a real problem for creating insecure software. Some of the tools, they're still doing their thing, but they just don't understand the software that you're creating. So bad things can just slip through the net. They don't tend to lend themselves to high velocity environments. And sometimes as a result, they might get bypassed. Finally, the lack of secure development education. I'm not expecting any of you to go, if you're watching this, cool. Well, maybe you are keen on security. That's great. But there isn't necessarily a path that includes secure development education. It's generally something that you have to seek out yourself. Goodness knows, I work in security. I didn't get here because I took the security course or anything like that. I actually got here in a fluky way because I was involved in software quality and craftsmanship, which is a thing, but directly affects security. And that slowly migrated me over. What a strange sort of weird backdoor way to get into this. So what can we do? Well, that's quite a bit. Now I'm going to go through a little Security for DevOps 101. Apologies if I'm... in Britain, we have a phrase which is teaching you how to suck eggs. I don't know where that came from. Preaching to the choir is another version of the same phrase. It's like weird. But the first thing is to know the attack surface that you're potentially dealing with the software that you are creating now, or the system that you are creating software for, maybe at a larger, more holistic scale. Second, associated with that surface, understand the attack vectors that might be used against you. Now, these are two phrases that I know are security phrases, and I'm never 100% certain that developers and ops and DevOps teams understand. They see it, or is it that front of mind? I know there's a lot more media using these phrases, but it doesn't necessarily mean people understand them. I mean, they're somewhat self-explanatory, but I'm going to get into them. The next is, and this probably sounds controversial, a bit of a hot take maybe, don't necessarily rely on security to help you. Because just because you don't necessarily know what to do actually doesn't mean that security knows what to do either. We live in an incredibly fast-paced, constantly changing software development world where the right security thing to do yesterday isn't always the right security thing to do today. Finally, when I say don't rely on security, think about open source tools. If you can help yourself out, even better. And that's what we're going to focus on today. What is my attack surface? Now, this isn't going to be individual to you. I'm going to take a holistic approach, right? Upwards of, oh gosh. So back when I used to write code, we wrote great big monster lumps of spaghetti code that was an absolute nightmare to debug. Now, the modern term for this is monolithic, represented here by this castle that I live in England. Easy to defend, big walls, moat, maybe a dragon or two, and a real big door. Security, old school, total. I mean, there's a reason firewalls are called firewalls, not actually a new term. This was a little bit simpler. Now, to define it, and you're probably going to say, Steve, did you get this from ChatGPT again? I'm not going to keep quoting it, but maybe the attack surface of a software environment is the sum of the different points, attack vectors, an unauthorized attacker can try to enter or extract information from. That's not bad. I'll admit I got it from a Wikipedia page. The monolithic example, okay, not too bad. I can see how to defend that. Cloud native version, that looks a lot more like a city or a village. Everyone lives in little containers or houses. There's lots of roads that connect and allow people to communicate. The edge doesn't always generally have a big fat wall around it. Lots of ways to attack a cloud native microservice environment. Sometimes there are more exposed areas near the edge, safer areas in the middle, and everyone's kind of responsible for their own little piece of cloud native property to try and keep it secure. And really, it only takes one person to not be secure to potentially create a vulnerability for the whole city. Now, taking a step back from that, this city communicates with that other city in the background. Well, can I compromise the other city in the background to get into this city somehow? And now we start getting to the definition of a supply chain attack. So there's a lot of things to try and think about. How do people have access to these things? You might even think, well, no one's going to attack me. All I do is X. Well, if X is used by Y and Y is used by Z, and Z is an interesting target, then you're actually an interesting target. Maybe even more interesting because you're not the one expecting it. Keeping the attack surface as small as possible is basic security. What is my attack surface? Well, I think we talked about a little bit. Open source software. If we know what open source we're using and we're scanning it and we're using tools to try and identify whether we've just decided to use something that could be the next entry point for my city, that's great. There are always vulnerabilities and dependencies. Supply chain attacks are generally carried out through very innocuous open source packages. The second one is exposed secrets. And that's another term that is very security centric, right? What's a secret? I don't know. I cry during romantic comedies. You know, it's not that kind of secret. Maybe I'm already revealing too much here, but it's something that we'll get into. It's generally like you think of passwords as a secret, but it goes far beyond that alone definition, right? And now finally, one that's becoming a bit more of a hot topic, and that's pipeline weaknesses or CI/CD environment weaknesses. And this falls more into the ops camp. This can mean you have misconfigurations just setting up your environment, or the environment itself has a vulnerability you don't know about or realize. There's been a few things that have been released over the years to do with Jenkins, for example. There's been vulnerabilities in GitLab. There's been vulnerabilities in GitHub. Pretty much nobody's innocent. And even more recently, Circle CI. So every environment, there are generally ways to crack into that. And amazingly, if you can get into one of the CI environments, okay, you have a potential major issue here because now you control the code. Let's break each one of these three down. I won't spend too long. Open source dependencies. Here's a little graph from cvedetails.com that just tracks how many open source vulnerabilities are released every year. You can see last year, 25,227. It's a lot. 2022 is a productive year. Now, do I think we're getting worse at writing secure code? No, I don't actually. I think we're just releasing a lot more code. And just with quantity comes quantity. I think we're actually creating frameworks and checkpoints that actually make security mostly better, but just the sheer complexity of people moving to cloud native away from monolithic and all the many moving parts and almost like a Rube Goldberg machine that represents means that we have more vulnerabilities. But we need to be wary of it. We need to understand that. We're only barely into 2023 and there's already 8,225. I think we're only really a quarter of the way through. So we're close to being on target for another, yay, record-breaking year. Now, the reality is 80% of your software is written by developers that don't work for you. You don't know who they are. That is a quote from, there's a lot of open source reports out there. There's thousands. There's open source security and risk analysis by some of my ex-colleagues who make that. There's a state of open source. They all have very similar numbers that say, look, whether you realize it or not, your software has got open source in it. Most of it was not written by security professionals. When I say most of it, that is a radical understatement. And bordering on all of it, right? We haven't written a lot of the open source with security at the front of our mind. And what's amazing is you think open source like OpenSSL that had Heartbleed would be, but even it can be susceptible and often is susceptible to intense scrutiny and has had a lot of vulnerabilities over the years that have been announced. Now, finally, what you consider to be dependencies, whatever's in your package JSON, your POM XML, or your pip file, these are the dependencies you have chosen for essential features and functionality that your application needs. But what if we go to those open source websites, what's in their GhostSum? What's in their package JSON? What's in their, what did they need to build their capability? How do I find out what that is? So those are called transitive dependencies. So we need to understand the entire depth and breadth of what our supply chain looks like for the dependencies we have intentionally chosen. It's kind of a big deal, right? Now, maybe as developers, that's a little bit beyond the scope of what we can do. But at the very least, we can look at our direct dependencies and maybe our first line of transitive dependencies ourselves, just to make sure that, get the low-hanging fruit. Here's an interesting example of one of these. Now, this is a display from our larger platform, which is Prisma Cloud, that does analyze these things in a more advanced way. Now, not something I would ever expect you to look at. This is for security people mainly, right? But it's a really interesting example of a very simple package JSON that has 5 key dependencies. But those dependencies have a lot of other dependencies that have a lot of other dependencies that have a lot of other dependencies. And when you start digging not that deep, you see that, well, wait a second, I have 2 versions of Optimist with slightly different versions. That's weird. And then I also notice I have a minimist here. Actually, this is a second minimist in the middle using a really out-of-date version in that version of Optimist. That's really odd. Well, Minimus, way down, we're almost 7 layers down in our dependency tree, had a pretty major bug last year or 2 years ago in 2021. And it was available, it was fixable, and it has a very, very low complexity to attack it. And all you have to do is bump that by 1. You can see, all you have to do is bump it by 1. You can fix it. So this is the sort of thing we're talking about, is how do we make that happen ourselves? All right, switch gears to leaked secrets. What does this mean? What are secrets? Sensitive information that should not be shared publicly, like the one I shared with you earlier. Passwords, API keys, any form of credentials. There's a wide variety of these options, and I'll show you a little bit of a hands-on in a moment. How are they leaked in the first place? Mistakes, mainly. Just include them right in the code. Lots of hard-coded passwords. It still happens. Sometimes you just put it in there for test purposes, and then you forget to remove it, or even you leave it in there commented. Hard-coded in configuration files. This happens a lot in Kubernetes. Just because it's base64 encoded does not mean it's safe. And people can get access to that. We can be in a little bit of trouble. Accidentally committing test files that might contain secrets. Very, very common. And then a little bit more of an obscure one. This does happen quite often. People are writing code, it's private. And when they release it into the wild, say, ta-da, here's my open source baby, they forget that they were pushing the boundaries of being private, and they had some information in there that really shouldn't go public when it did. Last one, weirdest one, commit comments. There's some great reports on this about how often verifiable API keys and tokens are included in the comment of a GitHub commit. I do not know how this happens. It does happen way too often. Very strange, right? You're thinking, well, that's not me. I can tell you honestly, personally, I have definitely accidentally committed an API key. I realized instantly I had to go deactivate. It just happens. And if you've never done it, well, congratulations. The last one, pipeline weaknesses, that might be a little bit more obscure for some of you. By the way, if you are in America at RSA, I will be doing a talk in great detail on this on Monday at 11 a.m. And so will my colleagues. You can see down there, they've got a session on the Thursday talking about another version of it. So it's pretty cool. There's a lot of really great ways to mess with people's CI/CD. Now, the first way you can have a weakness in your pipeline, let's use GitHub as an example, or there is an equivalent setting for just about everything else. It's just to have your branch protection turned off. Like, that's almost all your security settings turned off. Not do image scanning of images that are not part of your product, but used to build your product. That can be a great open door for attackers. Not scanning any infrastructure as code. And when I say that, I mean like a Jenkins file, for example, that defines what the build's going to do, or a GitHub Action Workflow YAML file. Those are still considered infrastructure as code. Not checking those to make sure that I haven't done something that might open me up for attack. Secondly, even if that in itself is fine, there are often input parameters to your build process that are not sanitized in a typical, like the way you would a form for a website. People put their name, their email, and you click submit. By default, when we're really good at checking those inputs to make sure someone's not trying to put something malicious in there, or even write a database query as their name, just to see if we use that to ask a database. And then suddenly they can exfiltrate all sorts of important information. We should be treating our pipeline and our build process as if it is an application in its own, and securing it in the exact same way. And I feel like up until recently, we haven't really had our eye on that, and it's really quite important. Now, a quick look at a branch protection rule example of how things can look good, but not good enough. When you turn on branch protection, at the very top, you can click a box that says require a pull request before merging. It's good practice, but the approval default is just 1. Okay, what ended up happening is the permissions for a GitHub token during a workflow should be this: read repository contents only. But the default is this. Now that bottom tick box is a very important tick box. Create and approve pull requests. So my now colleagues, formerly from cybersecurity, showed how you could submit a pull request and from within the pull request, run a curl command that automatically approves itself. This is the sort of thing we're talking about. Weird, but kind of cool at the same time. What can we do part 2? Well, I would be remiss if I didn't say that I'm biased. There are a lot of tools out there that can do a lot of really cool things to help you. I personally work very heavily on a tool called Checkoff. It's free. You can go get it at checkoff.io. The URL is down there. And it does a lot of cool things. It does scan infrastructure as code. It does scan pipeline to see if you've got set up right. It does look for secrets that are embedded in code. It does a version of software composition analysis and referenced images. It does a lot of the things I just said, and it does it all in one place, which is like, oh, that's very cool. What kind of infrastructure as code? I already mentioned it does GitHub workflows, which aren't listed there, but all the ones you could think of: Terraform, Kubernetes, Serverless Framework, CloudFormation, Ansible. The list just keeps going. If you can think of one, we probably cover it. I mean, just here at KubeCon again, well, yes, we do Kubernetes YAML, but we'll also scan Helm or Customize or any of the abstractions around that. So it's a very low barrier of entry to a lot of cool security. Now, very recently, and very experimentally, huge caveat, we added ChatGPT fix suggestions into Checkoff. And I'll show you a little bit about what that looks like, all right? And knock on wood, it all works. It's just providing very interesting additional insights into how to fix your code and make it better. And so far, it's working really well. Secrets detection and validation, and we have SBOM generation. So all of these things can be done with one tool. And now I'm just going to duck over here and show you what it looks like. So Checkoff is downloadable. Now I've got an example here. I just ran it. It's a little small, but I'm running just a Checkoff with open API key because I'm going to use the ChatGPT. I'm checking an Nginx YAML with the framework Kubernetes. Now I already just ran it, and I get a lot of information here because it's a Nginx YAML. It must be referencing an Nginx image, and because it is, I can see all the licenses that are inside that image. I can see all the vulnerabilities, and there actually is a critical curl vulnerability in it, which is troubling because I only just did this, and I'm referencing the latest Nginx image. So, I don't know what I can upgrade to, but we roll up, and we can see it's running on the command line, and there's a lot of great information. It's telling me, for example, let me just pick this one. It's telling me that if I reference an image, I didn't put even a version number. I didn't even put latest. I just wrote image Nginx, which is bad practice. So it's telling me I should use digest, which is correct. And it's shown me here, Nginx. Yeah, that's bad. What's interesting, the ChatGPT suggestion, now I know this is obscure, so I'm going to highlight so you can see it. It's showing me how to do that. Nginx at SHA-256 and go get the image digest. And you might be thinking, oh, how do I get the image digest? It told us how to do that. And I thought, oh, this is really quite cool. So this new version is quite good and very easy to use. Now I'm going to step back over here again and say, this is where you live. You don't live on the command line. So what I've got installed here, you can see down here, if you can, there's a Checkoff plugin that's in the marketplace for both JetBrains IDEs and for VS Code. And all those things I just talked about, which look maybe a little bit daunting, I'll show you just how easy it is. I'll do this first. Look, I've got a little bit of code here for an S3 bucket. Okay, it doesn't look too bad. And just interestingly enough, I created it using ChatGPT. I asked it to create me what it thought was a secure S3 bucket. You can see it's got encryption, but it's still missed a few things. And let me just, if I hover over it, Checkoff has created this annotation saying, ensure rotation for customer created SIEM case is enabled. Yeah, it didn't get that right. Well, how do I fix it? Apply fix. There we go. So that's how easy it can be. This is where we're talking about developer-centric security. Integrate a plugin, right-click, and suddenly you get fixes. That's not bad. We'll look at another example. So that squiggly line is gone. I'm doing okay. I'm going to move over to the Nginx YAML. Now, this is that very simple Nginx that I've got going on. Now, there are, if I hover over here, there are lots of things. A very simple Nginx is not the most secure thing. You can see lots of things that I'm not doing. I have no security context, among other things. But if you recall, I'm referencing this image, and if I hover over this squiggle, I can see the critical vulnerabilities that are in the referenced image. And I can see that right there in my IDE. I really, really like that. The shared secrets, if I click on no secrets in here, we can see that for every secret I've cut in here by accident intentionally, I can hover over and I can see, okay, we could tell that was a key just because it looks like a base64 high entropy string. If I go down to the stripe token, it's specifically telling me that this is a stripe access key. Same with Twilio. There's a whole variety of different types of secrets that are popping up by default. And that certainly does help me to remember that I need to make these fixes happen. So I like the fact that I can see secrets. What's even cooler now, and I don't have it in this demo because it's just so new, is that Checkoff has now gained the ability to validate secrets. So even if you think there's one that's just a test sample, if we know the type of secret, for example, some kind of cloud API key, we can also make a harmless check on that to say, this is not just a secret, this is a validated active secret. So that's a huge example. It's so new that it's like not here in this particular example yet. And the last one I want to show you, I talked about pipeline. So if I look at this issue grooming example, this is a GitHub action workflow. And what it's doing is every time an issue is created or opened, it really is all it's going to do is echo the issue title into the log. Now, there's lots of better examples of this, but I wanted to show you something specific, so I made a custom workflow where people sanitize issue titles. I saw a real-world example where when issues were created, they were adding the information to an ongoing blog page. And also, that's all sorts of bad. But what happens here, if you hover over this, we popped up, Checkoff is detected again. Ensure run commands are not vulnerable to shell injection. Okay, well, wait, hold on. How could that be? And I could click through here and I can look at the details, or I could just tell you, because I'm echoing in a little bit of a bash shell at that point, because it says run, it's going to execute this command. Well, if I create an issue title, and if you're familiar with bash, awesome. If you're not, I'll explain a little bit. There's a way of creating this backward tick, like a quote like this, put it in backticks. That tells bash, don't use this string, execute what's in this, and then use the result. Which means if I create an issue title in this situation that has backticks, it will run that command, which means I now have remote code execution on whatever runner is executing this particular workflow. And if it's a private runner, I might be able to get all sorts of bad things out of your environment. Very simple. And so we're highlighting that. I also liked is that just up here for a particular sample job, I decided to reference a container image of Python 9.3.9 Bullseye. And again, lots of critical issues in this particular image. And this is a great way of seeing that, oh, okay, so even my workflows, even my CI/CD, which could be under attack, is getting the same level of first-class security citizenship as my Nginx or my Terraform. And all of this can just happen right there as you're creating code before you've even checked it in, just using open source. I'm going to check the time. So that is the end. Wow. Okay, cool. I almost went to the end of the hour. The Code Smarter Hacker. Easy questions only, please. If that wasn't clear, you have any questions, the handouts are available for download. If you saw stuff you like, awesome. This is one of the first times I've done this presentation. So if you got any feedback, I would love to hear it. That's it. That's the end.
All right, Steve. So we haven't received any questions just yet. So I do want to have one more open call for questions. Anyone, if you do have them, go ahead and send them in. In the meantime, I did just want to remind everyone that we are recording this session today. You will be receiving the recording via email shortly after we conclude. It should be over to you in about the next in the next couple hours. And we also have a couple of winners to announce for our $25 Amazon gift card drawing. Our winners are Jesli C, Svetlana B, Yanbing L, and Mara M. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should be there in about 48 hours. But if you don't happen to see that, please do check your spam folder just in case it gets filtered out. All right, Steve, we did get a call. What is your LinkedIn? How can they connect with you?
Okay, I can do that. What is my LinkedIn? Oh, I don't know what the easiest way to do this is.
Did you have a QR code at the beginning of this?
I'm probably going to make you dizzy. Going back in time. Yeah, I did have a QR code at the beginning of this, which is you can scan, and it is me. There's not that many Giguere. So this is how this is me there down in the bottom corner. If you search on my name, there's just not a whole lot of us out there. So I'm pretty generally easy to find.
Awesome. Should be easy to do. Awesome. For someone new, how would you suggest to learn Chekhov.io?
Oh, great. No, we have in the same repository. So Chekhov.io will take you to the GitHub repository, which is under Bridge Crew, which is where we, the original authors of Chekhov. Under Bridge Crew, we have a whole bunch of intentionally wrong code. We have one called there's a TerraGoat, and it's all bad Terraform examples. So you can run Chekhov, you can just say -d Terraform goat, and you can see all the bad things happen and learn, okay, this is how we do it. It's pretty self-explanatory. If you just do a Chekhov-h, there's a lot of great parameters there, but you need almost none of them. Just -d directory or -f file, and away you go. You don't have to use any other commands. We even have a customized goat, so we've got all sorts of bad code there that you can download and play with pretty much right out of the box without having to do anything yourselves. Or you can do what I just did and go to ChatGPT and say, generate me some bad code, and it'll do it. Oh, it's great at it.
Oh, it's great at a lot of things, it seems. Well, Steve, I'm not seeing any more questions, so I do want to give you the opportunity in case that you have any parting words or closing thoughts for our audience before we take this off the air.
No, I'm just a big fan of open source. I think you can find open source that does just about everything you need. Obviously, it's very difficult to scale. If you're thinking on an organizational scale, do talk to us about how to do that. But yeah, no, go open source. And if you want to contribute back to Chekhov because you're an avid Python programmer, yes, please come and be part of the team. That would be amazing.
Yep, it's always important to support that open source community. Well, I would like to thank you, Steve, for joining me today. I learned a lot just sitting back and listening to you talk today. So I really appreciate the time that you take out of your schedule, your busy schedule of doing multiple presentations in a day and joining us on Techstrong Learning. So thank you for being here.
Okay, thanks, Cody.
I'd like to thank Prisma Cloud by Palo Alto Networks for sponsoring our program today. And to everyone who is with us, thank you for joining us. We really appreciate your time and we really value your feedback. As soon as we close out, there will be a survey that pops up. So please do fill that out for us. Let us know what you thought about our program today, or if you have any suggestions for a future Techstrong learning experience. Regardless, we do hope to see everyone at a future program. Have a great rest of your day, and you may now disconnect. Steve, thank you once again.
Thanks.